Today's class will be a quick review of some basic physics concepts that relates to motion, forces, and energy. Let's start with motion, movement. Is this spaceship moving? How do you know? Look at the vacuum cleaner. Did it move? How do you know? Let's look at the vacuum cleaner again. Here it is on the left side of the door next to the handle. Here is on the right side of the door away from the handle. We can say that an object has moved or is moving if it changes its position relative to a reference point. In this case, the reference point is the door or the handle on the door. Let's look at the spaceship again. How do we know that it's moving? Well, it is changing its position relative to the sea, for example. So the reference point is the sea. So again, motion is the changing of position of an object. So what makes an object move and change its position? Aha! These are the forces. Forces make objects move. Okay, then what made the vacuum cleaner move? Mr. Eldar. He applied force and moved the vacuum cleaner. Here is the vacuum cleaner again. It is not moving. Here is Juju. He acts like he is not moving. Oh, but he moves and shed a lot of hair that needs to be picked up or vacuumed up. All right, so here's the vacuum cleaner. It's not moving. You better move. Here's Mr. Eldar. Well, the vacuum cleaner won't move until a force will be applied on it. Well, Mr. Eldar is applying a force. He is pulling and pushing and pulling and pushing. Now it's moving and cleaning up my floor. So, a force is a pull or a push. Let's look at other examples. How forces create motion or movement. Okay, let's see what we have here. Here is the matgot, remember? The ball is released, it moved down, then it moved up, then it moved back down. What are the forces that act on the ball? First, the ball is being released and is moving down. What moving it down? Gravity. Gravity pull it down. Then you shall hit it. It goes back up again. That's the force that hit it, that go up. Now, the ball is moving again, downwards. What's pulling it down? Gravity. Gravity is a pull down force. So why the ball doesn't go through the racket, break it, and go down to the floor? Or why the ball does not continue to fall through the floor down to the center of the earth? Why does it stop? If gravity keeps on pulling on it, why does it stop at the floor? Why does it not continue going down through the floor somewhere? Well, this guy, he's kind of a big deal. His name is Sir Isaac Newton. He was a physicist and a mathematician, English person, lived in the 17th century, and he explained to us three very basic laws of motion. And the third one states that for every action, there's an equal and opposite reaction, meaning that the forces comes in pairs. For every acting force, there's an opposite acting force on the same object. Okay, sometimes these forces are invisible, so we kind of have to find out what they are. Look at this mug for example. Okay, gravity is pulling it down. The fact that it's not going through the table to the floor, that's because the table is applying force in the opposite direction up that holds the mug up on the table. And the forces of gravity and the table pushing back on the mug, it what keeps the mug in place. So when you have two forces in two opposite directions, but they are in equal strength, the object will not move. Here's another example. You all know tug of war. Here is Yeshai and Daphna, my dear children. They are pulling on this rope. Seems like they are pulling in opposite directions. The rope is not moving. If you can see the red mark in the middle, is kind of like staying in place. That's because they are pulling in equal forces. If the two opposite forces are of equal strength, the object will not move. Okay, they are applying forces, but no one right now is applying a greater force than the other. Well, here comes Mr. Eldar. He added his force to the right side of the rope. He applied more force, making the right side force greater than the left side force. Hence, the rope moved to the direction of the greater force. So, how many forces are there in a world? And what are they? Well, we already know a pull and a push. Scientists like to divide the forces to two types of forces. Contact forces, these are the pulls or the pushes that you can see the interaction between um, the objects, okay? Like hitting a baseball. You can see the push, you can see the bat hitting the ball, or like an engine. You can see the engine working and pushing the boat forward. The other type of forces, these are the non-contact forces. These are invisible. You kind of don't see them, okay? You don't see the push or the pull, like gravity or like magnetism, okay? Or like electrical field or electrical forces. Here you see my hair moves. If there is a movement, there is a force that is acting on it. What is the force that is acting on my hair to make it move? To pull it up. Okay, the static electricity. It's electrical field that was created around the balloon, and its invisible force is pulling my hair. So let's see what happened here again. Both my daughter and I applied force in opposite direction. First, the forces were equal, so the hand did not move. But then someone applied greater force and was able to defeat and move the other hand down to the floor. Lastly, let's look at a moving boat and count all of the forces that act on the moving boat and their direction. All right. So first we have the weight. That's the gravity that pulls the boat down. Well, the boat will sink down if there were not another force pushing back on it in the up or in the opposite direction. That's the up thrust. That's the upward force that is applied on a boat from the water. Okay. Then there is a force that is pushing the boat forward. We call it thrust. This is caused by the engines. The other two forces are the forces that's slowing the boat down actually, and they are in the opposite direction of the thrust. This is the friction with the water and another type of friction, friction with the air, or we call air resistance or drag. Now, can you tell which force is the greatest here that helps the boat move forward? Think about it and we'll talk about it in class.